And during that time, a certain number of you, after what seems like a really great interview where you've killed it and answered all these wonderful questions, I say, can you, on the whiteboard, code me up an elevator? And that's the extent of the question. And we've always left the question that open-ended because I want to know not exactly how to build an elevator. It's not like I've got a target in my mind. And I've reassured a few of you and said, don't worry, we don't actually build elevators here, so how this turns out doesn't matter. But it's interesting to me to see how folks approach the problem. I've had some folks that basically write me one class that says elevator, it's got an up method and a down method, and they're satisfied. Like, that's it, that's done. They don't work here, all right? But then I've got other folks. There was one fellow that I interviewed about the same time that Pranay was interviewing, who was fascinated with the safety of the door and spent 45 minutes just focusing on safety features around the door.
He got stuck when he was 3.
He got stuck. Personal reason. Some folks talk about the speed and weight of an elevator. Harris was talking about how the fact that no matter how many people are on the elevator, you need a constant speed. It's a really complicated problem, and how we approach that problem has a lot to do with how we think. I think it tells us a lot about how we think. So if you've done the elevator problem and you work here, like Pranay, we probably saw something interesting about how you thought about it. Well, I've done the elevator exercise 50 times, probably, which means I've spent 50 hours of my life thinking about the elevator problem, not all in a row. And I thought it would be kind of fun to grab all of you guys and kind of talk about it, and maybe I'll get started, but my hope is that between us, by the time we're done, I will have completely lost control of the whiteboard. You guys are talking about elevators. The other thing is that to some of you, actually many of you, object-oriented programming is kind of new, and I consider this an object-oriented problem. And I'm a believer in the object-oriented methodology because it's one of the easiest ways to encapsulate problems and distribute it amongst, what are there, like 25 of you guys? It's a very good approach to building business software at a large scale. And all of you have been taught object-oriented programming to some extent. Some of you are actually masterful at it. But you have the problem that I had when I started with OO, is that, okay, now I know how to make an object, what do I do with it? And that you're not going to find particularly well defined. There's no formula for it. I can tell you public this, private that, but when it comes to relating your objects to one another, that is where the artistry enters. And that's most of what we're going to talk about here. So my question, of course, is, the question now for you and me is, how do I code up an elevator? What kind of problems are we solving when we're building an elevator?
How to get people from one floor to the other.
Okay, so we have...
Or goods.
Yeah. So we're trying, and along the way, again, safety ended up being one. Speed and efficiency ended up being another. And when I started breaking down the elevator in the first place, you ever watch Sesame Street? Remember Sesame Street and the old elevator songs? And they always drew an elevator in basically the same way. So we'll start out drawing an elevator in basically the same way.
Yeah.
And if you're on the first floor, you're on a floor of a building looking for an elevator. Oh. To the left. Right away, with this goofy little picture, you start to break down, for me, I start to break down the pieces and parts. What's really funny is this isn't that different than when I look at a web page and start breaking down the pieces and parts of a web page. Right away, we need some way of calling an elevator, because that's what these buttons are for. So we have to, as a user, I need to signal an elevator. I need to get on an elevator, so we've got doors. Right here, I have a floor indicator to tell me what floor that particular elevator is on, whether I'm inside or outside. We've got the carriage that's actually going up and down. I'm going to call it a carriage. I'll bet it's got another name, but after doing this about 50 times, that's the word I arrived at. And the elevator itself obviously doesn't operate independently. So something is moving that elevator up and down. And as we get further along and we start optimizing our elevator, we'll add fewer or more elevators, or we'll make algorithmic decisions about who gets preference. But I don't think we need to go there just yet, although that's where you were headed, was preference and queuing. And if you ever go to our New York office, that's there are 50 some odd floors on the New York Times building. It's actually a very tall building, and they have 12 carriages overall. And you push a button, it tells you which carriage to get on, and then it doesn't go from one to whatever. It actually only services a certain part. So this can get really complicated. With this, I also decided that my elevator I was going to solve as a client-server problem. So the client would be me outside the elevator sending a message saying I need to go up or down, or I'm inside the elevator saying that I have to get to one of a number of floors. Alright, so all of a sudden I have 1, 2, 3. Let's say it's a 9-floor elevator and I have doors open and doors closed.
What about the fire button? Gotta have a fire button, man.
Fire button.
Or emergency, yeah. Heck yeah.
How's that for a fire button or a Pokemon? I'm not sure which. Right, so here again, client server, if I look at either of these as a client, then I have to send something, send a message. So I start to look at it as a messaging problem, a queuing problem. That's a whole lot of vowels for one sound. Which means that besides the carriage, we have lift, and we have the lift itself, which is, I think, of the motor that pulls the thing up and down. And then we have control of that. And I tend to start to put these together so that whatever is managing the messaging goes to the control and then manages the lift. So we get so far. So we're starting to break the problem down in kind of some interesting ways to make face.
Is that the Rebel Alliance?
That's what I was
That's the fire button. I invite you to draw a better fire button in front of 20 people with one of these. But it does somewhat. Yes, that is the Rebel Alliance button. So we started to break the problem down kind of an interesting way, and if I was now responsible for building an elevator, I would engage parts of you as teams to start solving some of these problems. But right away, our first experience of the elevator is to signal it and push up or down, and that's our first client, which means that I have a control panel that we have to work with. Even before I'm worried about the doors of the carriages, if we just approach it from a user problem, I have a control panel with 2 buttons. And so that's where I would end up starting to write classes. Or at least in this moment, the way I feel right now, that's where I start writing these classes. So I have a control panel class. And I think we can argue about this a little bit, but I also think we have a button class. Both of these end up being pretty general. I think a control panel is obviously far more specific than a button. A button is pretty basic, right? And we can think of it very simply as something I push. But I think we can relate a button to another kind of class, which would be a message class.
So is there an inside control panel and an outside control panel?
There is. But if I'm starting generally, I would kind of start here, all right? And that's kind of the idea of object-oriented programming, right? We're in a group. When we talk about classes, we're talking about classes actually in a classical Greek sense, right? Was it Aristotle or Plato both of them, when we talk about classical philosophy, we're not talking about it being old. That's not what classical means here. What we're actually talking about is the concept of taking the observable world around us and breaking it down into classes of things. Plato was all about breaking the world up into classes of things. So if we take animals, right, or just the natural world as we see it, and we break down life as animal and plant, or what do we have? Animal, plant, fungus. Right? Those are three classes of things. A class is simply something that you add individual items. It's a group. And our classes go from very general, like animalia, plant, fungus. We'll start there. And then we break down animal. And we can break down animal into mammal, bird, fish, however you want. And then you can break mammals down into, you know, four-legged, two-legged. Mammals are all pretty much the same. You know, you see how it starts to break down further and further and further. That's the problem you're actually solving when you're writing classes in the first place. So a button is a type of thing. A control panel, we have two. I think we have two types of control panels. So if I subclass a control panel, we do have the inside and the outside. But what's the control panel doing? Like, what are the component parts of a control panel right now?
It has buttons.
It's got buttons. Got more than one. There's probably a better way to represent it than an array of buttons, but for starters, we know we have a collection of buttons. What's a button do?
Send a message.
It sends a message, right? So I think there's a couple of parts to it. This is nice and easy, right? I click a button, it's going to send a message to, yeah, we haven't decided that yet. And the message is going to be, I am at this floor, and I need to go up or I need to go down. So I think we have a couple of things here. An outside control panel has a floor. Would we say that's a property of the button or the control panel, or do we need to talk about buttons more first?
We have the control panel.
Okay. I'm not worried about syntax right now. I don't think what language we're working in matters a whole lot. The button itself is going to have, that's a message. It's likely to have a label. Is that fair? A symbol, right? Something that I can read. Does that have anything else? Am I missing anything so far, or does this cover it?
Does it need to have like a state, like a link or not, basically?
It could have a state. I think it's whether it's active or not. Right, so if I'm on the ground floor and I hit the up button, no, but it's going to stay lit, so at the very least I know, as the person pushing the button, that something's happening. Right? Or that it's some sort of acknowledgement, so I think that's a state. That state could actually tie a little bit to queuing as well, right? Because something has to keep track of if I have 10 floors and 5 people trying to get to the ground floor or anywhere, that we have a number of now messages that are in a queue. And so that's kind of where your message comes in, right? I push the button sends a message. I have to imagine that a few things end up getting passed into the message, right? So if it's a simple call, well, what kind of message do we send here?
Push.
Push.
Well, that's the name of the method.
That's an event.
And this
Well,
would be like a
event.
request.
Yeah.
So you queue up the request that says, I want to go to floor 3, I want to go to floor 4, I want to go to floor 5. Something needs to be managing the queue of requests
Well-
to make sure that they're met and moving the elevator to each
Right,
floor each time.
and I think there's a couple of kinds, because right now, when I push one of these buttons, all the elevator can know is what floor I'm on and whether I want to go up or down. And so that's a call message. Let's call that a call message. Or a call request or whatever, right? And I'm going to tell it that I am on what floor I'm on and which direction I want to go. Right? So we can think of events because we have to assign events to things within our interface, but I think a button push is implicit to reality. You know, on a web page, we're modeling reality, but here we don't have to model reality. We actually have a button somewhere. All right, so I push a button and a message is sent to somewhere. We haven't defined yet. And it's going to say, it's going to be a call message, so we've inherited from message. We don't have anything special in message yet, so we may decide we don't need that. But we're going to send,
Redundant here, because technically, call message would just say floor.
The floor indicate what floor you are in.
yeah.
Yeah.
I don't think it is, because one, I have choices. So if I'm on the 3rd floor here,
Floor direction makes sense on the outside. From the inside, then you start.
you're right, but right now we're calling, our message is calling an elevator to our floor.
Okay, I see, going up or going down.
Right.
From where?
If we have one elevator, it could be as simple as first in, first out, or first in, last out, right? So and that wouldn't be satisfactory for anybody because that elevator may never get to the ground floor. But we can simply call an elevator to our floor. But if we call an elevator to our floor with a direction, then we have the option of optimizing. We don't have to get there just yet, all right?
And also another type of message would be, for want of a better description, an action message for your open and close in Rebel Alliance.
Yeah, well, that's you're right. So that's, again, another button with a message type. And
What do you state? So it's the same as the button.
do what?
So the button inside is the same as the button outside with a message and label and the state.
Yeah, totally. So at that point, we don't have to necessarily inherit from button. We're just instantiating buttons all over the place. So when we create a control panel, here we're likely to create a couple of different kinds of control panels here. I'm doing it again, aren't I? But this is just a great place to stand in the way of the camera so nobody can see it.
Right.
So where do we go from here?
Figure out what to do with the message.
Okay. Okay, so what handles the message? Where does the message go?
To the control.
Control? Well, okay. The
Control
button,
panel sends the message.
the control panel sends the message. Does that seem right? The button, every button isn't necessarily going to signal a motor somewhere. The button is going to signal the control panel, and the control panel is responsible for sending messages. What? Why? Why would we do that?
Because the control panel contains the best, all the buttons. That way
Sure.
you only have one connection to whatever you're queuing to.
Yeah.
So instead of 15 button connections or whatever to whatever you're queuing to.
Yeah, it simplifies the problem. So if you're on my team and I need you, if I've assigned your team or you as a developer to develop the control panel, all you need to know is the specification for a message going out from the control panel. You don't need to know anything past that. And then you have control over how the control panel registers events from, or handles events coming from the button. So we can expand on the control panel idea in a couple of directions now. One, to manage how messages are sent from the button to the control panel itself. And I think there's a queuing problem here as well to solve,
I think you
right?
need some kind of a elevator controller that basically the messages would go to.
Right.
That could actually work your queuing.
I think that's, well, there's two levels of queuing. You have the queuing for the entire system, but I think do you also have queuing at the control panel level? Here you don't, because no matter how many times I push up, I've only called it
I
once.
wouldn't worry about queuing on the control panel level. I'd have it where the mass elevator.
Well, we're
still be controlled.
we're not queuing the elevator now, we're queuing messages to control. I might be wrong here, but where I'm trying to dig in is if I'm inside and 15 people are in my car, and we have somebody who's pushed 1, 3, 5, and 7, do those messages need to be queued up at the control panel before they're sent up to control?
If you get sense of control, as you're hitting the buttons, it changes the state. As the messages are getting processed and your actions are happening, it comes back and messages what happens back to the control panel to alter the state of the button.
Okay.
So basically you have send message out, message gets processed, a result happens.
Okay, so if I hit 3 floors when I've entered the elevator, And we're saying that the control panel is gonna send messages to central control for all three of those, but it's not gonna manage those at all. Okay, that's,
Well, if you have like, did you just say you had like 3 different elevators perhaps?
no, we're inside now.
We just have one elevator. One
Yeah.
elevator, 3 floors
One elevator,
that you hit. 3 buttons.
yeah, I had 3 buttons that I hit, and we're saying right now the control panel doesn't have to manage a queue there. It's just sending a, that's fine, we have to make some assumptions right now, and
Can we
faced with the
map
problem.
it up, say, it's a flow and the person say, if we map it up, right, say 2% are going to third floor, 1% is going to the fourth one.
Mm-hmm.
So if we can map those things up, kind of hash mapping and all this, and if we can go to the map every time we reach a flow, get those index out if they have value 3,
Uh-huh.
boom, they're out, so queue is clear. Just next, then the 4 is remaining, you go to 4. If it's done, stay over there. And what's the next request?
Yeah, there's your queuing. So before we even have the queuing, Mark's point is we need a control, some control, central controller, and we kind of hinted at that when we started breaking down the problem.
It also gives you a good place to manage any kind of logic around, hey, are we close to this floor?
Right.
Because it will both have the queue, it'll receive the queue, but it can actually also prioritize and manage the queue.
Right.
And that's completely outside of the control panel of the carriage.
Absolutely, absolutely.
I know this was just discussed, but why did we decide not to control all that in the original control panel? Why are we creating a new class for all that?
For which? For the central control?
For the central control.
Well, with one
With
elevator,
one elevator, it seems like it can all be controlled from the control panel.
it does, but as soon as you add 2,
Right, as soon as you add 2, you need a central control.
right. Now, in this case, I would go ahead and do this because I would want, we're selling elevators.
No, that makes
You're
sense.
absolutely right.
Even the pieces and parts that you build into like something that is a centralized control, you can make that part of your control panel.
You bet, you bet.
Outside of it.
Well, in this scenario, there's at least 10 control panels. Because 1 for each floor plus the one inside the elevator.
Right, right. But with one, to Alex's point, and we can defend that for a second, this is a decision you have to make. With one elevator, the control panel does seem like a good place to manage all that queuing. From a code point, this is all abstract, right? But from a code point of view, you could do that. But if I'm an elevator company and my next elevator is gonna go to somebody who's managing their volume, I mean, this could be like a 3-floor apartment building in Denver, right? Or it could be 20 floor. I think with 10 floors, if whenever I stay in a hotel with 8 floors or more, they usually have 3 floors. So your ability to scale immediately comes from, you can either allow 3 elevators to operate independently, which I don't think is necessarily solving your scalability problem with the number of people who are going to be coming in and out, or you can centralize it, and your scalability is already built in. All right, so adding another class, classes don't come with a significant cost. A little bit at compile time, but that's why we have compile time. At runtime, there's no such thing as a class. So if your hesitance is to add another class, and that, like, there's no cost in doing it beyond your labor. So you haven't lost anything by breaking out the problem a little bit.
I think in this case, maybe too, we said that the up-down control panel is a control panel, and that isn't gonna have the same logic capabilities
Right.
as the in.
And I said at the beginning that I like to approach this problem as a client-server problem. So when I've decided on a pattern to apply to the problem, or let me rephrase that, when I've found that the problem reminds me of a pattern that I know to solve it, right? Then in this case, it's a client-server, and we can say that the control panels, and it doesn't matter which ones, they're a client, right? And if I really want to generalize, we can create a superclass that defines a client. And our control, do we want to call it control? Do we want to call it something else? MCP? This is our server, and now we're talking about a pattern that we're all actually quite familiar with.
It's interesting how similar this is to what we do every day.
Yeah.
And if we put a lot of logic in these control panels, it's very similar to how we bloat controllers when we don't need to. Instead of abstracting that logic into a library or repo or models or so forth.
Well, and in this case, our control panel more closely resembles our web page than anything else. because this is our webpage is our user interface. Here, the control panel's user interface with a much simpler problem to solve, right? But when I'm pushing up or down, I'm sending a message. We've decided we're sending a call message, and that call message now comes up to our control program.
Now, see, now that you've got server as control and you've got client control panels, you might want to turn the control panel instead of a parent class into an interface. Now you can build a contract between your client control panels and your server control. In
Well, but
case
then we're
you
not
wanted to come
sending,
up
do
with-
we? Do we?
No,
I would
no,
actually
no,
say
no.
that the message becomes an interface.
If you're selling elevators, then
Uh-huh.
you might, because now, like, depending on the building that's gonna install your new elevator, they might wanna have a wicked fancy control panel on the outside.
Oh, okay.
And you wanna kinda define the contract so that you make sure that it's needs buttons, gotta have floor indicators.
I still, I hear you, but I think it happens here.
Okay, it could be there as well.
I wonder if our
'Cause
message,
that's kind of, the message is kind of like the API, right? But the
That's exactly what it
control panel interface is kind of what drives the behavior in code. So it's where you could have an interface, where if you wanted to build an interface.
Okay,
or a
okay.
class on the control panel that did something a little different, it's got to make sure that it has to follow the same behavioral pattern.
that breaks things up a little bit here.
I just threw it out there. 'cause it's-
No, you're right, though.
Well, it's dependency inversion, right?
Okay, let's start with the simple one.
Oh, okay, sorry.
Let's start with the, you know, you're right. Let's start with the simple one. A message is real easy. Think about your thermostat at home. I'm thinking about it because mine's about to crap out and I need to replace it before winter.
Nest,
Nest,
Huh?
Nest. Get Nest.
look it up.
Oh, that's a brand.
Thermostat.
Okay. So I've got this furnace and I've got a thermostat that's not made by the same company. But I know that I can buy an electronic thermostat and hook it up, and whatever I do here is gonna control my archaic and possibly slightly dangerous 50s furnace. If I don't wake up one morning, we all know why now. So the messaging that takes place between, on this, at the simplest level, there's a contract defined between the furnace manufacturer and the manufacturer of my thermostat, right? And so, in order to allow the thermostat to be aftermarket, the messaging has to be standardized somehow. We describe that as an API. So, in the easiest sense, we know that the message is going to be passed back and forth. To Mark's point, there's actually some more complexity than that. Because in order to control our furnace, let me see if I've got you right. In order to control our furnace, the thermostat has to not only be able to send the right messages, but it has to be able to send all of the messages that are necessary to control the thermos. Is that what you're saying?
Yeah, it's basically got to have the same basic core functionality in order to interact with the furnace.
Right.
It can do other stuff, which is good. But
Sure.
it has to at least- Yeah,
Yeah, okay.
exactly.
Here, I think instead of I wonder if maybe if we change it or if we also implement an iControl panel. And I'm letting, not control planet. The reason for it is because two things are happening between control panel and the interface for the control panel. The control panel is ensuring that we have all the right actions, and that's our contract with control.
Yep.
But the implementation of control panel allows us to decide, how do I queue up, or how do I store buttons? How do I interact with buttons? That's actually up to me and my implementation of the control panel. How my buttons communicate messages to the control panel to be sent to control is up to me individually and isn't necessarily defined by the interface. Does that make sense?
So control will implement the interface of iControl panel, that's it. We are not bound by the client side to implement the interface, right?
I think the client said we are.
We are.
I think you
Yeah.
are.
Going back to the thermostat furnace example, the furnace is large, installed, expensive, long-lived, difficult to maintain, right? It's the thing that's least likely to change. The thermostat, batteries die, they're volatile, you got your hands on it all the time, messing it
Models
up.
change, you got Model 2000, Model 2010.
Right, right.
I feel like in this situation, you've got a lot more opportunity to customize and come up with different versions of the client control panel. And you need to make sure that it's always working the same way and consistently.
Yeah.
Like with message, you definitely put an interface, kind of like you described there. But you're probably building messages that are very exact and very specific for a reason. You probably actually have less need to customize and come up with more flexibility around the message. So probably less of a need to actually create the contract. The definition is the definition. But, to kind of make it abstract like this, you can do that too.
Well, I think it makes sense because the messages that are published by our control API are defined. And so sometimes I'll use an interface to define those. So it may actually be that when I buy my control, with it ships my API. And your interfaces are really great for defining APIs, right? So if control is a library that while we're implementing elevators is something I know I have to work with, I would look for that library to ship with message as well as a well-defined set of messages. And that's a little bit tougher because an interface won't give you that. That's your documentation.
Right, and then if you were to ever say like, maybe move out the responsibility of queuing and messaging themselves out of a third-party application, or this is off the queuing, this would also give you that contract definition.
Right, so if we use the New York Times building as an example, they probably have a pretty stock set of equipment for raising and lowering the carriages. The carriages are probably pretty stock. The interface matters a lot to the designer of the building. You want it to look right where it is. So your volatile, easily changeable control panels, they're obviously variable. And then when you talk about a queuing mechanism, they have a very advanced queuing mechanism where the control panels aren't up, down. On the ground floor, you push what floor you want to go to. And there's a very complex set of queuing algorithms that must be pretty badass that say, of these 6 carriages, or 12 actually, which carriage do I want this person to go on? Which carriage am I sending to floor 35? Which is the only floor I ever went to. 14, that's where the cafe was, too. All right, good so far? Where did we leave off?
So if we have an elevator, let's say it was X25 model, an X25 model, if the control panel is compliant with X25 model, we might have a selection of these 10 different control panels. And if it was compliant, then that would be our interface.
Right.
That it needs to do these certain things in order to work with this particular model. That's kind of what I'm getting at here.
Right, that's exactly right. And we're doing this by design, because early on as we're laying out this problem, and this could easily be your first whiteboard session for an entirely new line of business, right? And we're anticipating ahead of time where these things could be changeable. And that's the other neat thing about OL and interfaces in particular, is that you do allow certain parts of the system to be interchangeable. And we've decided from a business point of view that we want interchangeable parts. And so we're kind of anticipating that from the get-go. So this is like this is your first hour or two, or weeks, depending on how sophisticated your first round of work is going to be, into designing your object hierarchy or your object system when you're beginning to lay out a website. And notice there's no computers here. Right? It's not time to start coding yet. We're hours, man hours and man hours away from beginning to code, because we have a lot further to go. So we know now that we've got a generic set of messages, we have a pretty general idea of control panel. All of these need to be fleshed out. We've hinted still at a control, and we know that we're publishing an API to manage the control. What's happening in control? What does it do?
The logic.
It handles a lot of the complex logic and algorithms.
Okay, so it's got, first of all, it's going to queue up messages. Right. I'm not going to write down attributes here. I think just problems are good enough, but
Actually, send and receive messages, I think. So it'll need to send a message to the lift.
okay, so we have messages being queued in and out. Oh, we have dispatch, right?
Yeah, API dispatch.
Right.
Managing lifts.
Right. I think dispatch actually ends up managing the lift a little bit. As far as the lift itself goes, and when I'm talking about the lift, I'm talking about the mechanism that's raising and lowering the car. Right, so if we have a lift, and it's going to have an interface for control to manage, and that's two-way. So we have messages going back and forth, right, between control and the lift. We have messages going back between control and the control panel. Why doesn't the control panel talk directly to the lift? We already covered that, didn't we? All right, so how smart is the control when it comes to dealing with the lift, or how smart is the lift?
The lift isn't very smart.
Isn't it?
It's gotta have safety features.
It does have to have safety features.
The lift would have, move up, move down, stop, or move up to this, move down to that.
What kind of things about the building does the lift need to know?
The top floor,
Yeah, how many floors do you have, right?
And the controller.
Yeah, I mean, if it's on a cable, you,
No, you're right. You're right. There's other things, though, that I wonder if the lift needs to know more about. This is interesting. So not every floor, let's assume, I don't know if this is true or not, but let's assume that the distance between floors is different between different buildings, or the dimensions of the carriage and the distance between the floors. So what object needs to know that?
the lift needs to know what floor it's passing, whether it's being given that information or it determines
What
that
floor it's
information
passing?
before it's on.
the lift needs to know where it's at.
It might be,
Yeah.
it might need a list of floors.
Location.
Like, and if our floors are different heights, if the first floor has really huge ceilings, it needs to know
Control knows that, and just.
Yeah.
So the control.
Well, that's the question, is which mechanism knows this?
So lift should know the position, right? Lift should know its current position, that's for sure.
Yeah.
That's the starting point, right? Lift should know its current position. Based on what control passes, it can determine it, but position is required, right?
Can it be too?
I-
Well, at the very least, I don't agree here, or I don't.
To be honest, I see the lift as a dumb
Yeah,
device.
it doesn't do anything, it just.
That's the thing, it's like, where does the propulsion mechanism
It has
exist?
a load.
That's the
It's
lift.
like, yeah, so if it's in the lift, like if the lift is the cables and the pulleys and like all that.
That's what I'm assuming so far, or that's what I've always assumed during these exercises.
Right, and then like control is like basically a computer or something.
Uh-huh.
Versus the actual gearing and the mechanism and the cables and, you know.
But when
In
you're-
that case, the lift is not really dumb, it actually, it has to know how to crank itself, et cetera, et cetera.
Right, and so that's where I think certain things, like, I think it's important that it knows its current position. It's like a servo motor, right? Servo motors are actually smart enough to be able to report back to the controlling system its position. That's one of the things that makes it a servo. Right? A servo motor, if you have never played with electronics or mechanic, a servo motor, given an instruction, will move from a position to a position, and it's rather usually pretty specific, right? It doesn't just sit there and spin. It'll go from degree to degree, okay? And there are a lot of motors that do that. There are actuator motors that do that, but in reality, a servo motor, I think the thing that finally makes it, I'm not an expert, if anybody knows more about this than I do, you probably do, but it can report back where its current position is, and that's a certain amount of safety for the system works that way. So, long way of saying I agree on its current position, and it needs to be able to send that back. And any failures need to be reported back to the control as well.
Yeah.
Speed.
One consideration as part of the lifting mechanism is an indicator or some type of device that's at each floor entrance
Uh-huh.
that whether through some type of electronic signal or magnetic signal sets off a message at the lift that then delivers that through this servo motor to the control to indicate a status or location. But either way, in most cases, most of the information that's coming to or going from the lift is relays of messages and
Okay, so
information.
this all relates to door opening. And I
Right.
think we've entered another problem.
Well, no, just a status, a place.
Well, I think it's part of that. I think it's
I
part
don't
of that,
think
right?
our lift should necessarily be completely dumb, because when it comes to moving people around, I mean, there's quite often redundant safety systems in place.
Uh-huh.
Some lifts work off hydraulic type jacks, some lifts will work off of cables. But the lift needs to know if it's in a dangerous situation. If the control panel's telling you, if you're on the top floor and the control panel tells it for some reason, malfunctions,
Uh-huh.
tells it to go up, the lift needs to know that it's not
So we
supposed to
need
go out.
more like max and mean position too. So,
Okay.
so it's a kind of safety feature. Max position, that's a top floor, you can't go above that. Mean, that's the bottom or maybe basement or something like that.
Okay.
So,
So there
So
might
we
be
need-
some minimal logic in the lift.
I think it would need a speed controller to know when it's dropping too, right, to stop things. It could go really fast, that's true, but for safety wise, it would need to know.
No,
when
that's a really good point.
When it's spinning too quickly, to slow it down and stuff.
Well, even then, there's some fancier elevator systems that actually will go high speed between floors, and then ease to, ease from, so they don't make people feel like they're being blasted off.
The more complex our lifts get in the abilities that they have and the messages they relay, the more complex our control panel will get. Because
Now,
if
with
we're
the
talking
rail-
about a standardization or a protocol, an API of things that should be relayed to the control panel, if
Control panel or the control?
the control, I'm sorry.
Okay.
The more complex the information that's provided from the lift, if that information is being relayed to the control through an API, the control needs to be able to understand and interpret that.
I think that's true, but there's another way to think about what computation actually is, right? Because when you're starting to describe this around the lift, we can talk about yet another control that the control talks to, some sort of module like you have in your car engine that's handling these messages, but there's other ways for these messages to be relayed. For one, if you're talking about finding the position of the carriage on the lift, it can either be mathematical, and the lift is keeping track of it because it knows how much it's raised or how much it's lowered. But isn't there also the opportunity with, when given floors and given a carriage in motion, and I made my carriage taller than the floors, that when this point passes this point, there's an opportunity to send a signal, right? So the lift can be internally intelligent, right, to a certain extent. There's all kinds of accelerometers and stuff that can sit within your carriage to give you your speed detection. And this is something that you don't necessarily want to have in here. Think about all the autonomic systems within your own body that react without brain intervention, right? Certain reflexes, there's no time. It doesn't take long for a message to get to the server and back, but it could be too long, right? So if this thing is falling at an alarming rate, it seems like you'd have sensors within that would also trigger actions without, or excuse me, actions within. I think the brakes on the carriage are usually on the carriage itself, right? So if it
That's
goes
like
to-
the emergency brakes.
Right.
Like they sit on the track, like the track, like, yeah, exactly, the track that's
Yeah.
connected to it, like those things are like, set to like grab onto the track, like if the speed, like is set to like velocity, like road, like goes down to a certain amount.
Right.
Otis didn't invent the elevator, they actually invented the safety systems.
Okay. So if you're talking about an elevator like in the Great Gatsby, probably not a very smart lift. And, well,
It's actually
nowhere,
a really smart emergency brake.
yeah, it's just, or it might not have had it, but those are features that can actually be a part of the lift. So we may take, when I stayed at the Holiday Inn not long ago, they were lifting the carriage completely out the top of the elevator, right? And it's another interchangeable part. I don't know what they were doing, kind of scared the shit out of me because it was in the tower I was in. What was wrong with it? There was one in particular that was a little shaky on the way down. I wonder if it was that one. Right, but the lift is again interchangeable, and we can say that in this 1920s hotel, the original lift mechanism was probably pretty simple and probably didn't have a lot of safety features in it and has been replaced. And that doesn't necessarily have to mean replacement of the entire system or a new control. And actually in the Great Gatsby, I don't think they had, but they might have had a call button and some dude sitting inside going. How
You
much
could
time
argue
have-
that was way safer than any of this.
Yes, I don't disagree with you.
I think some of the things we're talking about as part of the lift though, might be part of the carriage, right?
Okay, so now we have a carriage class.
Like the lift has a carriage, or works with a carriage.
I think that's true, and I think we would scale by adding more lift carriage subsystems.
I think I structured it different, where I had server control to elevator, and then from there, the elevator controls, it's kind of lifted its own carriage, but
Well, you could combine these into a system. I don't know what you'd call it.
Elevator.
An
Elevator?
Yeah, just an elevator, because you can have multiple elevators, like in your New York Times scenario, 12 elevators to
Sure.
to the building.
Uh-huh.
In this case, the central control would tell what elevator, you go here, you go there, and from there, the elevator itself is autonomous, and it kind of manages its own. It just knows, I need to go here, I need to go there.
Yeah, so your messages from control to the elevator mechanism itself are going to be as simple as send the car to this floor. It could be really that simple. So this could be a rather complex subsystem that's responsible for the safety of that particular elevator. Some of this other stuff, speed. I mean, it sounds like it's all safety and simply moving from floor to floor. And a certain amount of two-way communication, because at any given point, does the elevator itself have to communicate back the presence of?
I think so, we need to.
Or is there complex modeling happening here where the control always knows where every car is?
Yeah, it should be, right? It should be polling the elevator to get the current position. So it can determine what's the next best step is. Since it will be, control will be handling the queuing stuff, we need to know where the actual elevator carriage is. So that's required, right?
Okay. And there's a time element to the managing of an elevator, right? Because it's not static, frame-based, what's my current state, what's my next state. There's a little bit of that, but not really, because it takes time for, it's not digital, right? It's analog, so it takes time for cars to move between floors. And while this car is moving down, somebody on the 5th floor or whatever can say, I need to go up. And control needs to manage that while knowing the current position of any, right? So if this is going from the 10th floor to the 1st, and after departing the 10th, I'm on the 5th, I say down, there's an opportunity to find me.
So is there like an elevator SLA, where if somebody's waited more than 2 minutes for their elevator
I think
to
so.
get priority?
I don't think anybody would give a damn, right? Like, I've been waiting here all day, whatever. But yeah, I think as your building scales, you do need to manage that queuing, and that complexity would be managed inside control. And if I was interviewing somebody that was very algorithm conscious, which I'm not necessarily, this is where I do well, and when we start arguing about the algorithm, I start to fall apart. But that kind of logic would be managed here, and that's been another part of that. I think when you and I talked about it, we did a little bit of the structuring, but a whole lot on the optimization.
Modern elevators too, like they're smart enough to have like base where they go to. So like large buildings, like in the morning, all the elevators stay at the bottom floor.
Okay.
Everyone's are going in to go up. At the end of the day, the end of the workday, they all have on the base floor at the very top. So
Okay.
basically go to the very top, and then they pick up everybody on the way down. Go all the way back to the top, pick up everyone on the way down.
Okay.
And like, and in the middle of the day, they just kind of like, if you have say 4 or 5 different lifts, well, kind of spread them out.
Okay.
Where they normally sit when no one's using them, so like,
Sure.
you can really quickly kind of grab everyone.
Another idea, yeah, for sure, and that would go into control, right? And that would be something that would be updated regularly.
You also need reporting metrics so that you can drive that kind of behavior.
Yeah,
So
it would
that
have to
you're-
feed back into itself, or at least report back to the designers.
Yeah. Logging.
Oh, definitely, I could definitely see
Our
loggers.
elevator units,
And then program.
Or elevators, you would need some sort of storage. You would need something. And I think that would change on whether it was something that would just be simply. So how many conversations do we have going on right now?
Doesn't necessarily report that.
Well, definitely, yeah, this definitely has a certain recursive complexity.
I guess they can
involved
sit
to
in
it.
the
Uh,
The deeper you get into it, the more complex you can get into
Yeah.
it.
Well, and when you're talking about the logging, and we have a decision to make there, whether it is simply static logging that gets fed back to the manufacturer, or somebody who's responsible for the tuning, or if you really get off on this sort of thing, or if our company decided that we had the business intelligence to do this, you could create a force feedback loop within your own system, and control could learn based on usage metrics and heuristics where the cars need to be and when, and can start to anticipate those needs. And if this is a office building or an apartment, I could see, well, about your only choice is Well, I think a hotel would be really sporadic, but an office building and an apartment building, maybe so more so an office building would have very predictable patterns, because the comings and goings of the people are gonna be more predictable, they're likely to be scheduled, that force feedback could come back. Or I could even see, would we decide as a company to design configurations so that when we're interviewing the architect and saying, how do we expect this business, this elevator to be, service this building, we say we have a configuration into that.
And then based on the configuration, you can get the right ad rotation in each carriage, since you got the right exposure to the right demographics.
And in Manhattan, that was definitely happening. That would be tricky, you'd have to detect
You get a body
if
count
the
too, I
volume
guess.
went up. I don't know if you'd have volume count if your volume, yeah, so there's a lot of interesting problems to solve for.
Wait, for speed?
No, load sensor, so, and it would have to know how many bodies though, so average weight of the person could determine the average.
So something, I want to point out something that our behavior is naturally reflecting right now. So when we started, then we'll quit because it's getting old. But when we started, we had a very basic and vague problem domain, right? And our first exercise, beyond trying to relate, so we draw a picture to try to relate to the problem we're solving in a very natural way. So this is very human. We begin to brainstorm and break down the problem into what, at first glance, we think our problem domain is, right? From there, we went with what seemed natural. I don't think that's a bad thing. We're dealing with brains here, a soft, squishy, organic computer. We're its victims as much as we're its masters. We begin to start to break down the problem, right? And as we break down the problem, we've already made some adjustments. We've started to find out where patterns emerge. Using our own previous experience, we've decided on a behavior, which was client-server. All right, so we've made some really high level, based on what we understand as humans, we made some high level assumptions based on experience. And we started to break down into pieces and parts. Now, just in the last few minutes, we had enough pieces and parts defined that we're able to start talking about behavior. And that's where algorithms started coming in, ad rotation, which is, I think, Mark being a smart ass, but it could be there. Logging, safety, all of these end up getting really specific. So again, you know, we started at the whiteboard and we started understanding the problem itself in a way that we could relate to before we broke it down. And then we started going in smaller, right? I didn't sit down right away. We didn't sit down right away and write an algorithm for queuing or define the XML for messaging, right? It was too soon. But we got to a certain point where now enough's been defined that we know where our complexity lies, and having divvied up the work, so there's 25 of us and we could have divided this up in any number of ways. Then we start talking about messaging in between. So if I'm on the lift committee, or I'm on the server committee, or I'm on the control panel committee, we know what teams need to start talking to one another and agreeing, right? So the social element comes out of this object design right away. We know that Adam's no good at algorithms, so we don't talk to him anymore, and we grab one of you math guys and start talking about where the algorithms go, what they are, but we know where they go. And we've defined enough interchangeable places that we have room to iterate and experiment, right? So we've broken down the problem enough that we can talk about speed to break ratios or message queuing and dispatching optimizations in such a way that it doesn't have to affect the control panel or the lift, right? So we've isolated our problem spaces such that they can be swapped out, iterated on, and experimented with, tested, optimized, without having a tremendous impact on the rest of the system. And when we talk about the rest of the system, what we're really talking about, the system that I'm concerned with as a manager, is the efficiency of the team. So this method, and us breaking down the problem this way, not only allows you to tackle the problem in an efficient way, it allows us to manage the team in an efficient way. So that's why we do it that way.
For those of you that don't know, Adam's really, really great with this big picture thing, and sometimes he somehow manages to get all the parts out there and know how they need to work with each other. So you saw the tendency for most of us was to get into details. How do you know when you have enough of these general pieces kind of sketched out? such that you can break it up? Like, what gives you that sense that we've gotten a sense of all the parts that need to play together?
Well, this is going to be a little disheartening. Some of it's time and experience, because I've been doing this for about 10 or 12 years, somewhere in there. So a lot of it's iteration. I used to play a game called Go, and it's kind of a tough game where the rules, it's like this, the rules are fairly simple, but they have nothing to do with how you play the game. Right, so the syntax for how to write a class, you notice we didn't give a shit about syntax here, we didn't talk about privacy, right? So you have to transcend a little bit of that. They tell you when you're playing Go and you're learning Go to lose your first 100 games as quickly as possible. And a lot of it's just iterating. But some of this is also feedback from designing systems and then living with their results. The first objects I wrote were massive. They were huge, and I would look at the problem kind of as a whole, and I wrote an object that managed the whole. But over time, having to maintain that, I found that things didn't break up that well. But I think some of this is just as simple as kind of being open to the problem and describing it to myself in human language. And I've talked to a few of you about this, I know I've had this conversation, when you come to me with a problem, which you do less of now, but you go to Melissa or Mark or somebody else, when you come to me with a problem and you start talking about AJAX calls and quids and whatnot, we're relating at an implementation level. And I don't necessarily know, based on your implementation, what problem you're trying to solve. So the first thing that I try to do, and I've worked with some of you long enough to have done this, I say, no, what are you trying to do? And when I say, what are you trying to do? I'm trying to move a person from the first floor to the third floor. That's what you're trying to do.
Because you have to talk to the duck.
Well, that helps. The duck helps. I spend a lot of time with ducks. But in object-oriented, none of this was based on C#. None of this was built on a particular architecture. None of the problem space that we've described here abstractly had anything to do with the implementation. I don't know the first thing about elevators. I really don't. But by relying on human language, we're using our classes to define the problem space. We're creating a language to define the problem space. And then you're working within that. So that's how I end up doing it, is as actually relating everything we're doing, not to the underlying architecture, not to the language, not to the database we chose or the limitations of the network, but always relating it back to a human problem that's being solved. There is no software out there that doesn't relate to some human need being solved. Whether you're controlling a dam, interacting with your bank, operating an RC car, all of these are addressing a human problem. If you always relate it back to that, then it starts to break down into some very logical, simple, and easy to relate to ways. And then you may have to optimize a little bit and start to shape this to the system that you're working on. I mean, there are constraints, and programming is always working within a set of constraints. And if you move from web to hardware, you're just changing the constraints, and everything else stays the same. Does that answer the question?
Let me add to that.
Yeah.
Specifically around like how much is enough. Because I think it comes down to the complexity of the problem and also the team that's going to work the problem. So you can break any problem down to 1,000 different pieces. And you don't necessarily want to identify or work out all 1,000 different pieces, at that high level kind of application planning. Somebody has to do it at some point in time, before you finish the project, because you have to have that blueprint to build. But when you're working at this level, you're going to be able to kind of come up with a hierarchy or taxonomy or some way to kind of build up, the structure that's going to hold those 1,000 pieces. Because that 1,000 pieces will fit into ultimately one application. That's at the highest level. It's the elevator problem. You can break that fundamentally down into a couple of different pieces, client server. Each of those you can start breaking down into more pieces. And you finally get all the pieces covered, where you know that, okay, I've touched everything, all the different pieces and parts. And bringing this to more like reality, you've got prototypes coming from design. You've touched all the pieces and parts of the prototype, and you've gone through your requirements doc, and you've touched all the pieces and parts there at a high level. That's probably done, to the point where you can start divvying up who's going to start delving into details and saying, kind of like Adam mentioned, it's like, hey, task force here, you guys figure out the lift details and take it the rest of the way.
Yeah.
But that's a lot smaller piece for them to continue to break down into the 1,000 pieces. instead of trying to do it, either one person or a small group of people, getting all the way down to the detail at the get-go, that's hard. So break the problem into smaller pieces. If you've got one person, well, you gotta do it all. You gotta go all the way.
Yeah.
You got 20 people, you can keep it up, what's the big 4 pieces, so we can start breaking the teams down and get down to the bottom.
And I think that those are limitations that'll kind of help, because I know now, I don't think a whole lot about this, I'm thinking more about projects, which is kind of the same sort of way, and we're solving the problem of building websites, a whole lot of websites with a whole lot of people in kind of a similar fashion, and I'll cut it down to the point where I know that I can give this to Melissa, and Melissa can handle it from there. If I'm alone and building a complex system, I'm not that sharp, and I can't keep a whole lot of complexity in my head. But if I know I've broken it down to, I can really just think about messages today, then that's probably small enough. Where if it's server, then that's going to require a team or a lot more iteration. All right, I hope that was helpful. Having done this enough times, I thought it would be kind of interesting to come back to it. I didn't know where it would land. I didn't have a plan. Because I thought it would be interesting to have you guys give some feedback as well. And as it turned out, it was. So next time you start a project, or you have, you need to solve a problem with code, and here it's C#, so it's always going to be OO. You can kind of rely on this methodology. I would also encourage you to come over here and grab one of these whiteboards, or any of them in the building, and any member of your team to start talking about this. Because even if you started 2 weeks ago and you're brand new to C#, your ability to contribute to this kind of problem solving is just as good as anybody else's, to tell you the truth. There you go. Thank you. Thanks for taking the time to do this. I hope it was helpful.